Good morning, everybody. I welcome all of you for the third day keynote session.
So, one pointer slide.
Yeah, I'll share.
Please share it and then.
Yeah.
Yeah.
Okay. So myself.
Hello, am I audible?
Yeah, sir. Wait a while, sir. Just to introduce you, and
Sir.
then you can start joining. Okay, start presenting, please. Thank you.
So myself, Dr. S. Gracelyn Jasmine from the School of Computer Science and Engineering. So I take immense pleasure and glad to welcome Mr. Navneet Bhushan. Navneet Bhushan is the founder of Crafty Consulting, Bengaluru. So he founded Crafty. It's an innovation, research and consulting firm at Bengaluru in the year 2008. So over a career spanning more than 2 decades, Navneet held positions such as Vice President and Head of Innovation with Hexaware Technologies, Principal Consultant with Wipro Technologies, CEO of CREAX Information Technologies Private Limited, Technology Specialist at Philips Global Intellectual Property and Standards Division, and Senior Research Associate with Infosys Technologies. Before joining the corporate world, Navneet worked for more than a decade as a scientist at DRDO. Navneet has extensive experience in the field of innovation, patent portfolio management, software development, management, research, and IP analysis. He has been providing advisory and problem-solving consultancy to a variety of industries in the decision engineering, innovation, intellectual property, and information technology landscape. He has authored more than 65 technical research papers and articles in various international and national journals. He is the principal author of book titled Strategic Decision Making, which has been featured at Harvard Business School, Working Knowledge for Business Leaders. So, dear attendees, if you have any queries on this session, you can post it in the chat box. Sir will be answering your queries after his presentation. So we welcome Mr. Navneet Bhushan to address the gathering. Over to you, sir.
Okay, thank you. Let me share my presentation first.
Yes.
Is it visible? This presentation is visible?
Yes, sir. Yes, sir. It is visible. You can make it a slideshow. Yes, sir.
Okay. So thank you for inviting me for this very interesting convention. Also, the time, typically I take a lot of time to speak, and my time management is not very good. So I would request you to point out if I am exceeding the time. Let me know if it is there. I am exceeding. Okay.
Sure,
So yeah. So the topic that I chose, and also I talked to the organizers, is to look at this as a future in terms of what exactly do we need ahead, given that what we have seen so far in the world that we are living, and there is a definite change that we are seeing, right? I mean, all of us know what has changed, and also the type of economy that we are looking at. So I just modified the topic a little bit in terms of the platform economy, and I will explain how do we apply these new thinking dimensions that are required for our future ahead. In that context, computational and algorithmic thinking, and also a couple of more thinking dimensions that we call the scale thinking and network thinking seems to be the need which needs to be supplanted or sort of synergize with the existing analytical or analytical logical thinking that we have already been used to. Also, we have seen what is called the value thinking, systems thinking, and inventive thinking. So we had in our work so far last 13 years or so in the company, as well as previously, as Madam said about my work. we have been looking at how do we think, what are the ways to think about problems and also design, also systems, so to say. There we have these 5 dimensions of thinking that we have utilized so far. It's called the analytical, logical, value, inventive system thinking that we have been practicing and also propagating, and to solve problems and also design new systems, or in fact creating newer type of functionality also, and leading to innovation and of course previously inventions. Now what we are seeing ahead is a shift towards what is called the newer type of creative destruction, as we call it. I will explain what do I mean by that. And then there we are proposing, and we are seeing this also a need to have new type of thinking, which we call the scale thinking, computational thinking, algorithmic thinking, and network thinking. Now, it seems these are newer type of dimensions, but the fundamental need underlying in all these things seems to be computational and algorithmic ways in which we create structures, procedures, as well as solve problems, or in fact, design new systems. In that context, the economy that we have, or the structures that are emerging, seems to be more and more oriented towards what is called a platform economy. And I will explain how do I apply this type of thinking and integrated thinking to a platform type of strategy creation for any particular platform that we would like to create, and also explain what is a platform. Then I'll sort of go through something about what should be the agenda ahead. Okay. So as Madam has introduced me, this is my profile. I worked for about 3 decades now. So I started as a scientist in DRDO, then worked as a various companies taking various type of roles, including technological as well as managerial and even chief executive roles also. Then we started in 2008 our company called Graffiti, which is helping uh, other companies, other organizations, and anyone else who would like to create something new. In fact, we offer to collaborate in all innovation contexts that we have, and that has been fairly successful now. This is the 13 years completing in May itself. So next, I mean, within 4 weeks, we will be starting the 14th year of our existence in this world. Okay. So agenda now is to maybe give you a brief about what changes that we are seeing, how these changes are going to impact us, and also about something about the innovation, and also specifying about the Always scan thinking. Scan is scale, computational, algorithmic, and network thinking, as I told you. And then also a little bit on the platform economy evolution, and how do we apply a particular tool and technique, so to say, called the General Morphological Analysis for platform strategy creation. So that is my agenda. Only thing I have is the problem of time. So if I exceed time, please let me know about 2-3 minutes before so that I can move ahead. So this is where we are in terms of what is called the 6th wave of innovation, we call it, which started in 2020, last year, and also will continue to be till next 25 years. But if you look at the previous waves of innovation, each wave was driven by a particular type of technological change that created or that transformed the world into a newer type of world, or industrial world, if you may, starting from the first wave, which was water power, textile, iron, towards the 5th wave, which is digital networks, software, new media, that we are moving towards the 6th wave, which we believe will be on things becoming nano. They will become network, autonomous, and hypersonic, and also using what we call the algorithmic intelligence. And in near future, next 5 years or so, quantum computing. These will mix together to create, give us ability to synthesize biology, energy, and reality itself. In fact, there is a study in 2016 which says by 2045, the high-level machine intelligence will be close to be a surgeon, a people or a doctor who does surgery on human beings by 2045. So this is really what we are looking at ahead. So it will be driven by what I think we already know. 2012 we started saying that we are getting into a newer shift towards what we call systems with an appropriate mind is what we are creating, and this will continue till 2035. And by 2030, quantum computing will become a main force combined with the artificial intelligence. We are looking at a very different world ahead, if you may. And this is where the creative dissection needs to be calibrated in terms of where do we need to play and how do we play the creative part of this dissection. Because what happens in this creative dissection? The previous economic systems typically gets destroyed or changed, transformed, and also a newer type of system emerges. So the typical approach towards this is what is called the innovation, which we define as successful creation of change through ideas. And we actually have a very complete framework of how do we do this innovation, or through looking at how to look at the problems or look at the opportunities or the needs, which we call the PONS, problem opportunity needs. But before that, we also need to identify what are our preferred and imagined and needed changes that we need to orchestrate. And that is where we need to find out the pin changes to sort of take care of the pawns, as we call it, and to using what is called the thinking, ideas, design, learning, and evolution, which is do the TIDDLE part. So this is our pin pawn TIDDLE framework. In fact, we have identified 5 parts of innovation. You can imagine a new future, you can transform an existing system, you can solve a problem after identifying, you can fulfill a particular user need, or you can develop a foresight and utilize that foresight to move to the next stage, so to say. In corresponding to each of these paths, we have structured innovation projects that we have. Now, here is the key part about what we are trying to explain, is that this framework of innovation, where if you see at the center, we have this Always Scan thinking, which is where the analytical, logical, value, inventive system thinking needs to be supplanted with a newer type of thinking dimension that we're talking about, scan thinking, which is scale, computation, algorithmic, and network thinking. Okay, so this is where I think a little bit of background about our work so far about this framework, and also looking at what changes that we are going to see ahead. In fact, it is going to be a massive change ahead. So we need to really look at what will change. Now, as you know, that most of the structures or the economic value is being created through something called a platform. And all the big companies are nothing but platforms, starting from Google or Amazon or even Facebook or Uber. All these are framed or some sort of a platform. What is a platform? It basically connects two type of markets from one side of an unorganized set of users and unorganized or organized set of providers. They get some sort of a in between mechanism, and that is where the platform comes. Amazon, Uber, LinkedIn, Facebook, Swiggy also is there. Now, how do we create this platform? And there seems to be a need for uh, evolving these platforms, as these are emerging more and more newer type of platforms are going to emerge. And that I think is a great opportunity ahead for all of us to explain and explore. In fact, there are a lot of books on this also I have put here. The key message is to how do we architect what is called the nudge, smart nudges in these complex choices through what is called the robust matchmaking on both sides is what is the need. Now, the platform economy is going to evolve now, because as we said, things are going to become more and more nano, hypersonic connected, and also autonomous. Once these devices become autonomous, we need to really see how human devices interaction will take place and how it will evolve. And there, I think the complexity will be much more. Now, since it is going to be more, last year I presented this concept called complex intelligent strategic systems. And I think this is where we need to really see how these systems can be orchestrated or designed And there, the complex strategic smart systems or intelligent systems need to be created as a holistic system upfront. And the platforms that we're talking about will be it's right in between these complex strategic systems and also the intelligent systems, which also indicates that we will be looking at more and more intelligent systems ahead, interacting. So here we have been talking about the so-called smart systems, but I think we already are in the realm of what we call the brilliant systems. But within, I think, 15 years or so, we will be getting into what we call the genius systems. And this, I think, is the age of smart systems becoming more and more brilliant, and also moving towards what is called the genius systems somewhere ahead. So, however, the key to this whole evolution is how do we understand information and thought is really what we need to get into. So artificial intelligence has been termed. It is intelligence that gets reflected in the output and behavior of a system or an actor. Whether the system is conscious in the human sense or is thinking of the human sense is not as important as what we sort of look at as the behavior of the system in the context in which it is. That is where the artificial intelligence should be looked at. However, there are certain questions about what is thought, how mind generate these thoughts. Is mind computation? Is universe nothing but a continuous computation? So here, of course, we need to get into a theory of computation, evolve that to newer type of areas that we are looking at. So we had this classical Turing machines, also probabilistic Turing machines that are also coming. Now we are evaluating these so-called thermodynamic Turing machines, where looking at the heat or the temperature perspective in terms of entropy, and also looking at the intelligence and entropy coming from physics. And in future, near future, we are going to look at how these quantum Turing machines need to be orchestrated and defined. And I think this is the area that maybe some of you can explore further. My point here is to look at the shift that we are seeing. And also there is this, what is called the Boyd's, John Boyd's observe, orient, decide, act loop to do anything. In fact, this is coming from military or the Air Force, but it is actually a framework for solving problems: observation, orientation, decision, and action. And in fact, if you look at this as a sort of a framework for type of autonomy that we are going to look at, there is this particular framework which says a variety of possibilities exist in terms of what type of complexity will emerge when we look at a variety of autonomous in terms of autonomy in motion, and also reaction times typically that we'll have. So a autonomous car will need to have very high speed reaction time to explore the traffic that it will be in. So that is, I think, the type of questions that we're going to ask or explore will be much more difficult and complex. And that is where we need to really have ability to do this prognosis and also combine systems or combine concepts which are quantitative as well as qualitative. Now, in a very interesting book, sometimes back, I read this particular book called Expert Social Scientists and the Techniques of Prognosis. Now, here it's very interesting in terms of looking at the future, or looking at a little bit about knowledge about the future. How do we create that? And that seems to be a fundamental problem, that the machines can give us some view, but I think some structuring, some thinking, and computational approaches are required for doing this prognosis. And I think that is the key part of it. There are three specific elements of prognosis: prediction, forecast, and prospection. Now, in the prediction, it is sort of a statement about the future without any explanation. But forecast and prospection are really what we should be looking at. There, I think algorithmic approaches for forecasting and prospection, algorithmic computational approaches for forecasting and prospection are, I think, the key requirements for future. So I will explain why, from the fundamental perspective, what exactly we are talking about here. So first definition is, what is change? Okay, so we talk about change, but we do not really have a crisp definition of change. And in fact, computational thinking is all about defining precisely all these aspects in such a manner that you can solve problems precisely, and also design systems in a very precise manner, and also explore human machine interactions in a very precise manner. So that is where the computational thinking comes into picture. As a definition of computational thinking is creating precision in terms of interactions, and also converting the so-called subjectivity, subjective concepts, into pure computational aspects. Okay, so patterns of reality in our minds get signals from our senses to indicate a deviation, which we call change, which we also identify, verify, accept, and then codify. And second definition is a variable. I think most of the people will know what is a variable, but just to say a specific aspect, quantity, or quality that can take specific value from a distinct, different, and distinguishable set of values at different times, condition, context, which we identify, verify, accept, then codify as such, is a variable. Now, if you use these two definitions of change and variables, you now look at two very interesting points about what is a trend, what is a pattern. So patterns are specific configurations of physical information or conceptual entities in space-time and or space-time, which are registered in our mind, or we identify, verify, accept, and then codify them as such. Whereas trend is a direction of change in time of a set of variables that we have identified, verified, accepted, then codified. Okay. Now, here one particular technique by a person named Zwicky, long back he was a physicist. He's organized this method called General Morphological Analysis. I think this is a very, very useful method of how do we look at complex structures and conceptual structures which are not very quantifiable. So here you can write down multiple dimensions and also their specific values in a table, tabular form, and then look at this is called a morphological field. And then you look at each particular dimension, what particular value it takes, and sort of look at that interactions between them in terms of their consistencies. Now, what we have used GMA or General Morphological Analysis, it gives us an early view and also acceptance of possible, plausible, and imagined elements of alternative futures or alternatives typically in a concept that we have, and also looks at the some sort of analysis in terms of consistency can be utilized. So there is a book called Wicked Problem Social Message which describes this method about, I think, a couple of years back this book came, which basically organizes all your conceptual dimensions, complete conceptual dimensions of any situation or a scenario or a system, and also look at the alternatives that you can take. And then it looks at this sort of a matrix which look at the consistency of each of these in terms of if you take one particular value, other cannot be taken. Okay, so this can give us what is called different type of scenarios. In fact, we can utilize these GMA type of structures to evaluate multiple options through these connections that we can create. And this can give you ultimately the best or the optimal, or in fact, multiple possibilities ahead, the plausible ahead. So I'll explain this. How do we apply this GMA tool to a platform strategy creation, which I think is the key message that I want to give in terms of where we need to apply. So when we said platform, right, platform combines or sort of integrates two different markets, so to say, and these markets need to be looked at from the perspective of what exactly is their size and how much variability is there. So first dimension of a platform strategy is to evaluate market sizes from both sides and also their heterogeneity or homogeneity, if you may. Second is you need to calibrate in terms of the ease, proportion, and access to that market. Now, both these questions need to be looked at from the perspective of how do we find out what sort of easiness or the proportion and the access to the market we have. Then market appropriate choices, architecture. Choice architecture for the people who are going to be participating in that market, they need to be given choices. And it seems the choice architecture plays a major role in terms of how each choice or multiple choices are presented to the participant, and he picks up a particular choice in a particular way. Now here, when you pick up some choices from one side, other side also some other participant will choose some particular choice. The algorithm or the platform need to do what is called the matchmaking, and that is where the algorithm need to be personalized, optimal, non-intrusive, and this is going to be a very big challenge ahead as the complexity of platforms and the interactions increases, right? So this, I think, is the key questions to be explored. Then how do you nudge people, nudging strategies on both sides to participate and also pick up a particular choice which will help them to get maximum value. Then there is a, how do we scale up a particular platform in terms of number of participants increasing exponentially or in a very rapid manner. And I mean, this is where the business strategy needs to be built into the scaling as a scaling strategy here. Then innovation focus, whether the business model, strategy, or management need to be sort of changed simultaneously or one by one, or any particular individual that we need to focus on. Then how do we orchestrate these so-called network effects across the markets on both sides, and establishing what is called the product market fit in terms of the solutioning that you are providing in terms of the market that is available to you in terms of. So these are the 9 questions which we call the 9 dimensions of platform strategy. Now each of these has 4 values in our framework, potential values each of these 9 dimensions can take. So we have identified 4 different values. For example, let us say the matchmaking, personalized, optimal, non-intrusive algorithmic matchmaking can be personalized, optimal match using current criteria and information. Second option can be first come, first serve match, global optimization based on stored preferences. And fourth one is the evolutionary and learning based matchmaking algorithm. Now, which one, of course, each one will have a specific type of complexity in the context in which the platform exists. Now, how do we choose and how do we look at what are the constraints of choosing a particular type of option in each of these dimensions? It seems there are interactions between them, and that is where general morphological analysis helps us to identify the consistencies upfront and also constraints and the plausible options between these values. And this matrix is where we sort of fill up upfront, or it can be filled up by a data that we can capture from multiple sources. And this matrix, once it is filled, it can give us this picture about the plausibility as well as synergistic possibilities of choosing a particular value on a particular dimension. Okay. Also, it also gives us the constraints. So red dots here in this matrix, you will see are the constraints that we're talking about. Okay. Now, given this analysis, it will, based on these constraining options and the choices that we have made, the system, this general morphological analysis can give us a particular type of a platform strategy that can emerge through these interactions. So the approach that we are talking about is we are looking at computational as well as the algorithmic mechanism to define and also let the strategy emerge also. I think this is a big change compared to the previous type of work that where the strategy was given to strategic type of questions were typically given to maybe the CEOs or the stakeholders or the management or the human beings. But here, I think once the inputs are given, the methods and the consistency using GMA, we can create some sort of a options and also the constraining parts with through this computational approaches, we can create a platform strategy. So coming to the final points about why this is important is in terms of the perspective about the way in which we are approaching future or future is approaching us seems to be so rapid that it is becoming very difficult for us to cope up with the pace of change that we are looking at. It is approaching it faster and faster, but we are not letting go of our history with that sort of it. So the problem is, how do we make ourselves more creative, given that we have a particular problem of being subjugated by the education system that we have, or the society that has given us this particular problem. Problem is that all of us were born creative, but it is taught out of us through our education. In fact, there are studies which says child's creativity decreases 90% from age 5 to age 7, and at age 40 it is mere 2% of what we had when we were at age 5, and that I think is a big problem here. Now I think just to sort of summarize what should be the way ahead for us in terms of our approach. And there we are seeing the learning model for the next 25 years. And a lot of studies, a lot of books are available, and which sort of says that we are looking at a age of what is called a polymath, profiles in compound technology innovations, which basically means you have to have knowledge of multiple fields and also ability to learn multiple fields at the runtime, also utilize those fields with an openness to craft solutions at the runtime. This is going to be a challenge because we have become so much of subservient to the expertise based education system and learning system that we have, and I think that needs to be changed. Now here we are saying that if you want to really do this, you need to shift from the I-shaped people learning models that we have in the previous waves, and or the T-shaped people that we have been creating in the fifth wave of innovation, towards what we call the spiral learners, who will be we need to create dynamic ultra learners throughout their life, who are going to be passionate to learn by expanding their range of skills, thinking and domains to transform into what is called a evolutionary learner who is designed to evolve through continuous learning. And that I think is the key framework that we're talking about. So in a spiral learner will do this natural action as well as using the natural as well as thinking in a natural way, plus artificial actions and artificial thinking also, in terms of combining all these four quadrants into a way in which you spiral through the complexity of the maze that you're going to get into. Now, the key message here is the passion, creativity, and initiative needs to be developed. And if it is not developed through the education system that we have, we need to sort of see how do we maximize the possibility given the constraint that we have. Okay. Now, here we have looked at from the perspective of uh, how do we do that, and we call it the innovation co-crafter. Here, you need to really look at three stages of solving problems or looking at you need to accept that you do
Sorry,
not
sir,
know.
to
And that
interrupt you.
hello.
Yeah, sir, sorry to interrupt you in between. So it's a time for us to conclude the session. So maybe in
Okay.
another 1 or 2 minutes.
Okay.
Maybe.
Can I take 1 more minute?
Yes, sir.
Can I
Yes,
Yeah, you
take
sir.
can take
1
1
minute?
minute, sir.
Yes, sir.
Yeah, please,
Yes, sir.
please.
Thank you. Yeah.
Hello.
Yes, sir, you can take 1 more minute, sir. Please. Thank you.
Okay. So just want to give you a flavor of these innovation co-crafter or the crafter model, which basically said that we need to have these 10 traits of innovation crafter. He needs to look at sort of establishes a system of innovation, explores something called the uncommon part of this, learn spirally, becomes a polymath, and you do what is called a deliberate innovation practice, follow the fourth paradigm of learning through data analysis along with experimentation, uses what we call the 7Ps and 7Ds, and also look at how do we invent strong always rather than trying to solve the problem at the surface, and explores the 9 key dimensions of problem system framework and establishes what is called the enterprise innovation canvas. So we have specific tools for each of these phases of the process, soul, Elvis, CAD, craft that we talk about. Different type of tools are available. The questions are also very clearly defined upfront. And finally, I would like to say that why we need to really look at this is because we'll just quote from Herbert Simon's book called Sciences of the Artificial. Herbert Simon won the Nobel Prize for economics long back. But he says our essential task is simply to keep open the options for the future, or perhaps even to broaden them a bit by creating new variety and new niches. And I think this is the key message why we need to keep on exploring newer ways to solve problems and also newer dimensions of thinking, as we call it. So I don't know whether we are justified in the time that we have. But I think the key message here is that if you have to craft new choices for innovation and decisions for the uh, world ahead, and specifically to solve this creative uh, destruction that we have in this what is called the VUCA world. It is basically variable, uncertain, complex, and ambiguous world that we have. We need to really explore newer thinking dimensions, specifically what we call the scale, computational, algorithmic, and network thinking. So I have my email and also my mobile number here. You can send a mail if you have a question. I'm sorry about the time. I don't know whether we have time for questions, but thank you for the opportunity and also listening.
Thank you, sir. They may post you the questions in mail. Thank you. Ma'am, just email
Yes,
can come
sir.
to main room.
Yeah, okay, sir. Thank you, sir. Thank you for sharing your thought-provoking speech.